Hey guys, video over the quotient rule. Let's see. We have h of x is f of x times g of x, a rational function, a meaningful rational function. And g of x can't equal 0. So when I say a meaningful rational function, I mean we do not have a rational function such as h of x equals, let's say we have like x squared minus 7x plus 1 all divided by x. This isn't a meaningful rational function because each term in the numerator can just be divided by x, where we would simplify this to be x minus 7 plus x to the negative 1. And then we can just take the derivative of each one of these terms separately. What I mean is that when we have two legitimate functions of x divided by each other, so if we have like 3x plus 1 over 7x minus 3, now we have a legitimate rational function. It is not difficult to do the quotient rule on this, but we can't simplify this in a meaningful way. So the derivative when we have the quotient rule is, if we did that limit definition that I talked about in class, we'd end up with this. I'm just going to show you the shorter version that we end up with. It is going to be the bottom function multiplied by the derivative of the top function minus the top function times the derivative of the bottom function over the bottom function squared. So when we do the quotient rule, we end up with the possibility of the denominator equaling 0. And that's going to introduce what we call vertical tangents. A vertical tangent is going to mean that, all right, so we're basing this on h prime. So we're going to mean where h prime of x is undefined. And so that's going to be where the denominator equals 0. Sometimes the denominator is never 0. If we had something like the case of x squared plus 7, that's never going to equal 0 because x can't. The answers are the square root of -7, which aren't real numbers. But it is something to look out for when people say find vertical tangents. It's going to imply that you have a derivative that has a denominator, and you want to just set that denominator equal to 0. So I'm just working examples again from the textbook. If you want to follow along or find these problems, it's page 126 to 129. I'm starting out with number 7. And number 7 is, we'll just say y equals x over x squared plus 1. And all right, so for all of these, we are just finding the derivative. We're going to write our derivatives in a bunch of different ways. So when we're doing the derivative dy over dx, that's going to equal, this requires the quotient rule. So we would have the low function x squared plus 1 times the derivative of x minus the top function, which is x, times the derivative of the bottom, which is 2x, over x squared plus 1 squared. Over here, I'm going to make a note that we should never expand the bottom or the denominator. And then I'm going to put a star by that. And that's only in special, the star is just for special circumstances. Most of the time for algebraic functions, we don't require expanding this. It's not helpful. So we can simplify, and for the quotient rule, most of the time simplifying is just going to mean simplifying the numerator, where we would get x squared plus 1 minus 2x squared. Don't forget to keep the denominator squared. And so this is negative x squared plus 1 over x squared plus 1 squared. And no, we cannot cancel out x squared plus 1 over x squared plus 1 because this is a negative x squared. So we're done right here. Next example we're going to do is number 11, where we have g of x equals, let me move up, we have sine sine x over x squared. Point of order is that we can't cancel out x over x squared. It's a thing I've seen in the past. Don't do that. The derivative is going to be the low function, which is x squared, times the derivative of sine x, which is, we'll just put cosine x in parentheses, minus the top function, which is sine x, times the derivative of x squared, which is 2x. So it's perfectly fine if you want to put the 2x in the front because you know that the 2x should go in front of the sine x. And then we divide by x squared squared, so x squared squared. And so we will get as an answer x squared cosine x minus 2x cosine x over x to the fourth. So everything has an x in common, so we can reduce by 1 power of x. We have x squared, 2x, and x to the fourth. Everything goes down by a factor of 1. So we're going to have x cosine x minus, okay, mistake here is that the sine x and this turned into a cosine x. This should be a sine x. So ignore that mistake. My apologies. So x squared cosine x minus 2x sine x turns into x cosine x minus 2 sine x over x cubed. And that's all we can do. That is all we can do. So the next example we're going to work is number 58. Number 58 has us doing, we're going to use different letters. So f of theta equals sine theta over 1 minus cosine theta. And we are still finding, you can't see any of that. So we are still finding the derivative, and we're going to have 1 minus cosine theta times the derivative of the top, which is cosine theta, minus the top function, which is sine theta, times the derivative of the bottom, which is 0 plus sine theta. So positive sine theta over 1 minus cosine theta squared, which gives us, let's see, on the bottom, on the top, we're going to have cosine times 1 is cosine theta minus cosine squared theta minus sine squared theta over 1 minus cosine theta squared. So we're going to do some fancy stuff for a moment because this actually simplifies a good bit. We're going to have on the top, we're going to group these first two terms. Well, imagine for these two terms, we factor out a negative. So we're going to have negative sine squared theta plus cosine squared theta, because that's still negative sine squared or negative cosine squared, plus cosine theta over 1 minus cosine theta squared. Now, just so we're clear, you can stop here for me. It's simplified enough, but if you were working this on like a multiple choice test or something, they would go all the way applying the identity sine squared plus cosine squared is 1. So this is a negative 1. So we have cosine theta minus 1 over 1 minus cosine theta squared. Now, the difference between cosine theta minus 1 and 1 minus cosine theta is a negative 1. So this is actually, so you can see this, we get cosine theta minus 1 over 1 minus cosine theta times 1 minus cosine theta. Now, again, this is beyond the scope of doing the quotient rule, because the quotient rule is just this step. Everything else that we're doing is algebra and technically trigonometry, because we're using trig functions. But cosine theta minus 1 over 1 minus cosine theta, that is a negative 1. So the final answer is just negative 1 over 1 minus cosine theta. And that is it. So the next example we have is probably the last one that we're going to do for this video is just number 76. So 76 is what we have. F of x equals x minus 4 over x squared minus 7. And let's do a bunch of different things. A, we're going to find the horizontal tangents, which means, again, horizontal tangent means that f prime of x equals 0. And remember, for a rational function, it's going to equal 0 when the numerator equals 0. So our derivative is low function x squared minus 7 times the derivative of the top, which is 1, minus the top function x minus 4 times the derivative of the bottom, which is 2x, over x squared minus 7 squared. So if we simplify, we get x squared minus 7. Don't forget to distribute a negative 2x. So that's going to give us minus 2x squared plus 8x over x squared minus 7 quantity squared. And so if we fully simplify this, we get negative x squared plus 8x minus 7 over x squared minus 7 squared. So since we're finding horizontal tangents, we're finding where f prime of x equals 0. That's where the numerator equals 0. So we're solving the equation negative x squared plus 8x minus 7 equals 0. Let's see. Now that's the same as if we had x squared minus 8x plus 7 equals 0. We just multiply everything by negative 1. And that would just be x, well, what are the factors of 7 that give you negative 8? So x minus 7 and x minus 1 equals 0. So x equals positive 7 and x equals 1. If we had to find the point where where f of x has horizontal tangents, we would take each of the x values that we found and substitute them back into the original function. And so we can do that. F of 7 is going to equal 7 minus 4, which is 3 over 49 minus 7, which is 42. So 3 over 42 is 1/14. And then f of 1 is negative 3 over negative 6, which is positive 1/2. So we have a horizontal tangent at 7 1/14 and 1/2. And for B, if we were finding vertical tangents, that's going to be where the derivative is undefined. So we're taking x squared minus 7 squared and setting that equal to 0. The first thing I want you to notice is that we don't care about the square, because the first thing we would do down here is take the square root to get rid of x squared minus 7. And so we would just have x squared minus 7 equal, the square root of x squared minus 7 squared is just x squared minus 7. And that equals 0. So the square root of 0 is 0. So we add 7 to both sides. We get x squared equals 7. And so x equals plus and minus the square root of 7. So that's where we have vertical tangents. We can't have, x can't be positive square root 7 or negative square root 7 in the original function, because that would make that equal 0. So we only have x values where we have a vertical tangent, no y value, because again, we cannot substitute square root 7 in for x. And for C, just for fun, let's say we want to write the equation of the tangent at x equals, let's say 5. So if x is 5, then, and so to write the equation of the tangent line, we need, so we're writing the equation of the tangent line at x equals 5. We need f prime of 5, which is, so that's going to be negative 5 squared plus 8 times 5 minus 7 over 5 squared minus 7 squared, which is 25, so negative 25 plus 40 is 15, minus 7 is 8 over 18 squared. So 25 minus 7 is 18. 18 squared is, I believe, 324. I'll check my math on that. 4 divides into both of these, so that's going to be, well, 8 divides into both of these, right? Nope. 4 divides into both of these, we get 2 over 81. Yeah, let's go with 81. Check me on 18 squared. It might not be 324. I don't have a calculator with me. Let's find out though. 18 times 10 is 180, and 8 times 18 is 124. 8 times 18 is 4, carry the 6 is 144. Yeah, so it's 324. All right, I'm correct. So then f of 5 is going to equal, we have to substitute 5 back into the original. That's going to be 1 over 25 minus 7, which is 18. So f of 5 is 1/18th. If you can see that. So the equation of the tangent line would be y minus 1/18th equals 2 over 81 times x minus 5. And if we wanted to, we can get rid of this and put it in standard form, but we're going to say this is sufficient because we have very ugly numbers. So quick review over what we did. The quotient rule is f of x divided by g of x. The derivative in the sing-songy way is low d high minus high d low over low squared. Vertical tangents are going to imply the derivative is undefined, and we should never expand the bottom. Sometimes we can cancel, as we did in the example for number 11. If you have more questions, talk to me in class. The next video is going to cover the chain rule, where we start applying the product and quotient rule together while we're doing the chain rule.